Welcome to this video where we will learn how to install, configure, and use iiQKA.StateControl in iiQWorks.Sim. We start with a layout that is already created in iiQWorks.Sim. It includes a robot, 2 conveyors, and a sensor on the first conveyor. When we start the simulation, the creator generates a green cube that moves along the first conveyor and triggers the sensor. Meanwhile, the robot moves to the conveyor, waits above the cube until it receives a signal from the sensor, and then moves over the second conveyor without picking up the cube. Let's have a short look at the signals and how they are mapped in this demo. Output 101 is linked to the open signal interface of the gripper, 102 to the closed signal interface. The closed state is connected to the input 102 and the open state to the input signal 101 of the robot. The output 1 of the robot is connected to the engine of the roll conveyor. Now, we want to use iiQKA.StateControl to trigger the gripper and to start and stop the second conveyor while the robot places a new cube. To do this, we first need to install the KUKA option package through the software repository. In your layout, click on the KUKA robot. In the component properties of the robot, scroll down to the option package configuration dropdown at the bottom of the window. Open the available options via the drop-down menu. If you installed the package via the software repository, you will find the iiQKA.StateControl option in the list. Click the plus symbol on the right to add it to the robot. A new window will appear asking you to approve the modification of the robot configuration. Click OK. Now, iiQKA.StateControl will be visible under assigned options in the robot properties. Next, go to the Home tab and open the Devices tree. Navigate to the controller of the robot, then to Option Packages. Click the plus symbol to expand the menu and select iiQKA.StateControl to access its settings. Here you will find useful information about dependencies, documentation, and license details. Make sure to review these before proceeding. In the General Settings menu, you can enable or disable Ghost Mode. Check the documentation for details on what Ghost Mode does. You can also adjust the interrupt priority here. Next, go to General Signals. This is where you configure digital inputs and outputs for features like Ghost Mode and error events. In the Error Strategies menu, click the gear icon in the top right corner to add or modify strategies. Now, let's configure the devices. In the Device Configuration menu, click the plus symbol to add a new device. You can also use the gear icon to edit an existing configuration. Add a new device and you will see it appear in the Devices tree with signals and switching states. Select the new device, click the gear icon, and rename it. For our application, we'll call it Gripper. Then, add a second device and name it Conveyor. Assign an object to each device using the drop-down menu or by selecting it directly in the 3D world with the yellow cube icon. Use the Show Device in 3D Scene button to confirm you selected the correct object. You can adjust settings like state check timeout or pulse duration in milliseconds. For this example, we'll keep the default values. Next, configure the signals. In the Devices tree, select the Signal menu for the gripper. Use the pre-configured inputs and outputs or click the plus symbol to add new ones. Rename them to something meaningful, like in our application, Input 1 will be named to In, Gripper is open. Input 2 will be called In, Gripper is closed. After clicking on the gear, Output 1 can be renamed to Out, Open, and Output 2 will be renamed to Out, Closed. Then, go to Switching States for the gripper. Change the names and descriptions if needed. We'll keep them as Open and Close. Set the Boolean states for inputs and outputs by clicking the empty value and selecting true or false, depending on your application. In our example, for the open state of the gripper, the in gripper is open must be true and in gripper is closed false. The outputs, out, open, must be true, and out, close, must be false. On the other hand, for the closed state, we configure in gripper is open to be false and in gripper is closed to true. The outputs, out, open, must be false, and out, close, must be true. For the conveyor, we only need one output. Delete the inputs and one output using the red X icon. Rename the remaining output to Out, Conveyor On. In switching states, rename Open to Conveyor On and set Out Conveyor On to True. Rename Close to Conveyor Off and set Out Conveyor On to False. Once all devices and states are configured, the last step is to map the signals in the I/O mapping editor. This ensures the robot program can control the gripper and conveyor correctly. To do this, go to the Configuration tab and click on the I/O Mapping Editor. You can also access it by clicking the small arrows in the Properties of State Control. A new window will open in front of your 3D layout. In the Scene Elements section, select the KUKA robot you want to work with. In the I/O tree, navigate to State Control and expand it using the plus symbol. Then, open the Device Signals section and select the device you want to configure. Here you will see all the inputs and outputs you created earlier in the State Control configuration. In the second I/O selection panel, navigate to the KUKA robot and find the digital inputs and outputs of the robot. Now, select the signal from State Control and the corresponding digital I/O from the robot. Click the blue link symbol in the middle of the window to map them. For example, in our case, $101 is mapped to in gripper is open, and $102 is mapped to in gripper is close. Then, for outputs, $out101 is mapped to out open, and $out102 is mapped to out close. Finally, map the conveyor signals. For example, all conveyor on from State Control is mapped to $out1 on the robot. Once all signals are mapped, the I/O configuration is complete. Now we can proceed to programming the robot using State Control. Go to the Program tab and click on the KUKA robot. In the Programming window, navigate to the program you want to edit. In the Programming Functions, click on the State Control icon. This icon is only visible if iiQKA.StateControl is installed in iiQWorks.Sim. From the State Control drop-down menu, select Set State. On the right side of the screen, in the Statement Properties window, you can adapt the settings depending on your setup and program. First, select the device you want to control. Then, toggle the state using the drop-down menu to one of the states you defined earlier. For our example, we will set the gripper to the closed state and select Strategy 1. You can also add a wait time or a check with an error strategy, or enable or disable monitoring if needed. Next, we add another set state command to open the gripper later in the program. Now let's run the simulation by clicking Reset and Play. You will see that the robot moves down to the first conveyor, grabs the green cube, and places it on the second conveyor as planned. However, the conveyor is still running while the part is being placed. To fix this, we want to stop the conveyor during placement. Go back to the State Control drop-down menu and select SynSetState. In the Statement Properties, set the device to conveyor and the state to conveyor off. Insert this command at the right position in the program, just before the robot places the part. Then, add another SynSetState after the placement and set the state to conveyor on so the conveyor starts moving again. Run the simulation once more. Now you can observe that the robot picks the green cube, moves it to the conveyor, stops the conveyor, places the cube, and then starts a conveyor again as the robot moves away. That concludes this State Control tutorial video. You have learned how to install, configure, map signals, and program devices using iiQKA.StateControl in iiQWorks.Sim.
We appreciate you watching. Don't forget to hit the subscribe button on the KUKA channel for updates and new videos. For hands-on trainings and courses, head over to the KUKA College. Keep exploring and learning with us.
Making automation easier.